Hello, y'all, and welcome to this video that I wanted to make for you, where we will begin looking at our exam review for Conic Sections. And so I've pulled up the exam review right here, and we are going to start by looking at questions 1, 2, 3, and 4. Now, we took notes on the equations of a circle, an ellipse, a hyperbola, and a parabola. But we took notes on these equations written in standard form. And when you look at these equations, you might realize that those are not written in standard form, right? And these equations are written in a way to where you can do some algebra and complete the square and do a bunch of algebra tricks to try and get these equations in standard form. But I am going to teach you a trick where you can just look at these equations the way they are, and you'll be able to tell, is it a circle, an ellipse, a hyperbola, or a parabola? So I have put these equations into Desmos over here, and we are just going to first look at them one at a time. So here's the first one, and do you know what it is? It's a hyperbola. Hopefully you recognized this hyperbola from all of the time that we've spent graphing them. And we'll look at the second one now. Is it a circle or an ellipse? It's an ellipse. Notice that it is more of an oval shape. It does not have the same radius all the way around. So this is an ellipse, not a circle. And we'll look at the third one. This is a circle. And the last one, is it a hyperbola? Nope, this is a parabola. And you might be thinking that's a sideways parabola, but it is a parabola opening to the left. And now I want you to look at these equations on the left of the screen and specifically just look at the x squared term and the y squared term. So what do you notice about the x squared term and the y squared term? Hopefully you noticed that the coefficients are different and there's a minus sign right here. So one of them is being subtracted, and this matches the notes that we took on the equation of a hyperbola in standard form. Remember that we have two fractions and a minus sign in between. So either the x squared term is being subtracted from the y squared term, or the y squared is being subtracted from the x squared. And when we see the minus sign between those two terms, then we know that it's going to be creating a hyperbola. And now what do you notice about the x squared term and the y squared term in this equation of an ellipse? Notice that they're both positive. The x squared coefficient here is a positive 2, and the y squared coefficient here is a positive 3. So when you look at these equations, if the x squared term and the y squared term are both positive, then it's going to be an ellipse. And what do we notice about the x squared and y squared here creating the circle? This one, notice that the coefficients are the same. First thing to notice. Second thing to notice, they're still both positive. So the coefficients here are just a 1x squared plus a 1y squared. But even if these coefficients were both 2s or both 7s, it would be making a circle. And so when they're both positive, looking at the ellipse here, when they're both positive but they're different, it will make an ellipse. when the coefficients of x squared and y squared are positive, but they're the same, it will make a circle. And finally, what do we notice about the x squared and y squared terms here in the parabola? There is no x squared. Good. Whenever we see one of these equations and there's no x squared in there, then it's going to be making a parabola. So now I want you to look at your paper again of your exam review, and I want you to circle the x squared terms and the y squared terms and notice if it's positive or negative, and then try to figure out, is it a circle, an ellipse, a parabola, or a hyperbola?